All right, we're going to be solving for a variable here. Usually it's for y. Again, if you haven't tried this on your own, you shouldn't be watching this video yet. You really want to make sure you've done as much as you can on your own before getting help. Once you have gotten help on something, it means you didn't know how to do it all the way on your own, so you need to go back and practice it before the year starts. So we're going to be solving for y. You might notice there's a plus c in a lot of these problems. That's because there is a bunch of calculus problems that involve plus c, and we'll get to that near the end of the year. But we do need to be able to solve these. So we're trying to get y by itself. And so here we've got y inside of a natural log. And we're going to do e to the power of both sides. Now, you can't just do e to an individual thing. You have to do e to the whole side. Here there's only one term. But here we have to do e to the power of both sides. And so it's to this entire side. So here we get y plus 1 equals, okay, e to the x squared plus c is written like this, and there's a cool trick we can use that we're going to need to use later this year in calculus, which is that if you have something to a power with the same base, you can add the exponents together. What we'll notice is we have two things added together here, and so what we're going to do later this year is we're going to separate this into e to the x squared times e to the c. But that should be a property from Algebra 1 we already know. And then we need to subtract 1 on both sides. So here we are, y equals e to the x squared times e to the c minus 1. Now if you were doing this on your own, I would expect you not to have done this and to have just left it like this, which is fine. But we're going to need this in this form later this year, which is why I put it there now. Okay, for b, we want to get y by itself. So we're going to get the squared by itself. We multiply by 2. And again, we multiply the entire side by 2. This is a binomial. So it becomes 2 times 1/2 is 1, 2 times 1/2 is 1, 2 times c is 2c, and then y equals, we're going to do the square root on both sides. It has to be the square root of the entire side. And I hope you notice that I've made a small mistake here. I've made a mistake that I see a lot of students make, which is that when you take the square root of both sides, it has to be plus or minus. These are actually two different functions that create a circle. So this by itself, this would just be a semicircle. This gives the bottom half of the circle, and it's necessary. All right. Over here, there are two ways to solve this, and I'm going to do it in two different ways. The first way is to multiply by what's in the denominator. So we can multiply by y plus 3 cubed. We have to multiply the whole side by y plus 3 cubed. And what we get is 1 equals 1/3 x cubed plus c times y plus 3 cubed. Now we haven't really gotten y by itself yet. It's being multiplied by this big thing, and so the next step is to divide by what it was being multiplied by. So the way we do that is we just divide by this guy. And so we get 1 divided by 1/3 x cubed plus c equals y plus 3 cubed. To undo cubing something, we do a cube root. So the cube root of the whole side, that's y plus 3. And so we get the cube root of 1 divided by 1/3 x cubed plus c minus 3 is y. That's one way to do it. There's a slightly shorter way when the whole thing is being divided. One thing we can do is we can think of this as 1 times y plus 3 cubed to the negative 1 power, because it's dividing. Dividing is a negative exponent. And to undo this, we can do a power to a power, which is we just do it to the negative 1 power. So we can do both sides to the negative 1 power. And what that does is it basically takes both sides and it flips them. You can do the reciprocal of both sides. And so here we flip it, and here, this will be our second method over here. We just flip it, and it becomes y plus 3 cubed equals 1 divided by 1/3 x cubed plus c. And then we can take the cube root on both sides, and it gets us to this same solution just a little bit faster. So that's a nice little trick. Yeah, same thing here. This is we could rewrite it. We can do this two ways. We could do this as -1 over y minus 2, because that's what the -1 means, equals 2 cosine of x plus c. We could multiply by y minus 2 to get it out of the denominator. We have to multiply the whole side. And then we have to divide by, to get y by itself, we need to divide by what it's multiplying by. And then add the 2. So -1 over 2 cosine of x plus c plus 2 equals y. Or at the very beginning, we could just, we should probably divide the -1 to get this by itself. And so we would get y minus 2 to the -1 power equals -2 cosine of x minus c. And then to undo this, we would just do to the -1 power again, which the reason is when you do a power to a power, they multiply. -1 times -1 is 1, and y minus 2 to the 1 power is just y minus 2. And if we did that on this side, we had to do it on this side also. So this is 1 over -2 cosine of x minus c. And you might notice that these two solutions look a little bit different from each other. And that's okay. These are equal to each other. There is no better form, but these are the same. They're just written differently. Okay, I think that's enough of those. Let's look at this technique in H. What makes this different is that there are two y values here. There's a y in both of these. And so how do we get y by itself? Well, there's a technique we use, which is to get a single y, we take everything with a y in it and factor out the y. So y times 2x gives me 2xy. Y times -3 cosine of 3x gives me -3y cosine of 3x. And this 5x doesn't have a y in it. So I'm going to leave it out here. It's not being multiplied by y because it didn't have a y in it. And now to get y by itself, all I need to do is get this alone. So we're going to move the 5x. Basically, we move everything that didn't have a y in it to the other side. And we divide by everything y is being multiplied by, and that gets the y by itself. All right, that's it. This last one is a pretty simple algebraically, but has some trig stuff in it you need. So we're going to get y by itself, so we need to subtract the tangent x on both sides. So y secant of x equals 1 minus tangent of x. So y equals 1 minus tangent of x divided by secant of x. Now, it says to simplify this. That means we're not going to leave it like this. This can be simplified quite a bit. This comes up, this is very important in calculus for the multiple choice questions because you'll get an answer like this and it won't match any of the answer choices. And so you need to be able to simplify things. So the easiest thing to do when you see a bunch of trig things is to change them all into sines and cosines. You do need to know, and you should have already mastered this, your trig mastery stuff, you need to know what tangent is. Tangent is sine over cosine. Secant is 1 over cosine. And the way you divide by a fraction is by multiplying by the reciprocal. So 1 minus sine of x over cosine of x times the reciprocal of 1 over cosine of x is cosine of x. So we multiply by the reciprocal. This will distribute. Cosine of x times 1 is cosine of x. Cosine of x times this, well, the cosine divides and multiplies, that cancels out, and we get minus sine of x. So y is cosine of x minus sine of x, which looks a lot better than this thing. Even though these are equal to each other, this is how the multiple choice answer would be written. And so we want to be able to simplify with our trig proofs.